So you might know Kayla Osterhoff, a recent graduate from Mind Body Medicine. She graduated in 2024. And you might also know that she also earned certificates in hypnosis, neurofeedback, and integrative functional nutrition. She's a former CDC scientist. She's expert in women's health and committed to advancing women's health through innovative research and systemic change. During her tenure at the CDC, she led large-scale public health initiatives across several countries and played key roles in major emergency responses, including Zika, Ebola, and COVID-19. With a career focus on public health policy, Dr. Kayla now dictates her expertise to women's health policy reform, addressing gender gaps in research and education, and developing solutions that reflect the unique biological complexity of women. Tonight she'll be talking to us about the neurophysiological physiology of the female biorhythm. And her presentation explores menstrual cycles beyond reproduction by analyzing neurophysiological biometrics across three hormone phases. So data from 31 women were collected with wearable technology and EEGs, and it revealed distinct neurophysiological patterns. So I will allow her to explain her results and welcome Dr. Kayla. Thank you for being here.
Thank you so much for having me. Um, are my slides showing okay? Just want to make sure.
Yep, looks good.
Yeah. Okay, great. Um, as you mentioned, my dissertation was looking at and mapping neurophysiological biometrics across the female menstrual cycle, and showing evidence of a female-specific biological rhythm, which we'll talk about in a moment. So the problem, women actually represent a major gap in our health science research that still exists today. And this was perpetuated by the 1977 FDA ban of women from clinical research, which actually remained in effect until 1993, when the Office of Women's Health was formed at NIH, and they decided that we should probably start to include women in research. But even since 1993, when we started to require that women be included in clinical studies, we still have a massive underrepresentation of female subjects within our research today. And one of the reasons why is because of the biological complexity that the female menstrual cycle presents within the global physiology of female subjects. The majority of research that is done specifically on females is dedicated to reproductive health typically, and women's menstrual cycles are only primarily considered in the context of reproduction and not in the context of how the ebb and flow of estrogen and progesterone through the menstrual cycle impact the entire female physiology. So due to this gender gap in research, women's physiology and biological complexity that results from the female hormone cycle is not well understood, and that is what my research focused on. This is not a new problem. This is something that has been in our media and in our news and has gotten a lot of acknowledgement in the last 15 years or so. However, we have still not made great progress in closing these gender gaps in our health science research and data. So the purpose of my study was to explore the physiological effects of the hormonal phases of the menstrual cycle beyond reproduction by measuring and mapping neurophysiological biometrics across three distinct hormone cycle phases: the menstrual cycle, which is when estrogen and progesterone are at their lowest level in the menstrual phase; the late follicular phase, which is when estrogen is high and progesterone is low; and the mid-luteal phase, which is when progesterone is high and estrogen is low. And my purpose was to better understand the monthly female biological rhythm outside of reproduction. So by mapping these neurophysiological biometrics across the menstrual cycle phases, I was able to address the following research questions. Um, I did it in two sets. So the first set of research questions were focused on the wearable biometrics. And the first question was, are there differences in women's heart rate variability as measured by a wristband wearable device between the menstrual, late follicular, and mid-luteal hormone cycle phases? And then the rest of the questions, 2 through 8, were the same, but with different biometrics. So we also measured resting heart rate, respiration rate, blood oxygen saturation, arterial elasticity, light sleep, deep sleep, and sleep efficiency. Then I also ran a small case series with just 4 of the research subjects that were included in the total group to collect EEGs from them in each of the 3 hormonal cycle phases across 3 cycles. So 9 EEGs were collected for each subject, and the research questions related to the case series was question 9. What differences exist in women's default mode network EEG activity between the menstrual, late follicular, and mid-luteal hormone cycle phases as based upon pattern analysis? And then I also looked at the salience network, the pain network, the memory network, and the depression network of the brains for the same questions. Methodology consisted of collecting daily autonomic biometric data from 40 normally cycling female participants using the BioStrap wristband wearable device, and phase-based EEGs from three of the participants, one of them dropped out, using the neuron spectrum 3 across 3 full menstrual cycles. Examination of within group differences were looked at in HRV, resting heart rate, respiration rate, blood oxygen saturation, arterial elasticity, sleep, the different sleep metrics, and the EEGs between the phases. The analysis, I'm going to skip over this part and we'll get to the more interesting piece. We'll skip over data handling. This is just how the data were collected, handled, and stored for each type of data. So here are the significant results by phase, and then we'll also talk about the results by research question. So each of the 3 hormone cycle phases examined did exhibit distinct neurophysiological patterns that repeated across all of the subjects, showing evidence of a distinct female biological rhythm outside of the reproductive cycle. So in phase 1, which was the menstrual phase, it exhibited across subjects a consistent lower resting heart rate and sleep efficiency compared to the mid-luteal phase, and along with notable alterations in the default mode network delta connectivity specifically. In phase 2, which is the late follicular phase, it showed the highest heart rate variability across subjects, lowest respiration rate, and increased deep sleep biometrics in comparison to the menstrual phase, phase 1, along with notable changes in the salience and pain network beta connectivity. In phase 3, which is the mid-luteal phase, it consistently exhibited the lowest heart rate variability, highest respiration rate, highest resting heart rate, and decreased deep sleep in comparison to the late follicular phase, along with notable changes in the default mode network, delta and alpha connectivity, and the pain network beta connectivity. These are just showing each one of the results. So I'll kind of skip through these. And I wanted to show this part. So for the case series, within the default mode network, the pattern analysis revealed that there's a repeating connectivity change in a pattern that repeated across all 3 menstrual cycles in all 3 cases. So I thought it was interesting to show you the actual pattern here. So if you look, phase 1 is here, phase 2 is here, phase 3 is here, and then it repeats. Second cycle, phase 1, phase 2, phase 3. Third cycle, phase 1, phase 2, phase 3. What's really interesting is you see the same pattern repeat. It starts here, decreases, increases. Then we go here, decrease, increase. Here, decrease, increase. So this is showing that this is a discernible pattern, and these changes between phases are consistent and happening across all cases in this default mode network, which is really interesting and also raises many more questions, but does show evidence that there is a broader global physiological rhythm that is in accordance to the changes in hormones during the menstrual cycle. The salience network, you can see the same thing, even though this first one is a little higher than the others, but the pattern remains the same. And this is the salience network connectivity patterns that changed across all 3 phases. So again, you can see the pattern repeat. It kind of goes up, then down, and then starting here, up and down, and starting here, up and down. So again, a discernible pattern that repeats across all cases and across 3 menstrual cycles consistently. You can kind of see the same thing here, though it's not as discernible, and it wasn't across all three cases. It was across 2 cases, but the variation in beta connectivity within the pain network did show that there was a pattern that changed across the cases. So again, you can kind of see a discernible pattern, oops, but it's not as obvious as the other ones. And then we'll skip through. So commonality across all cases within the case series, there were a few that were notable. Within the default mode network and the salience network, they consistently exhibited distinct changes in connectivity pattern between menstrual cycle phases, which does suggest a shared hormonal influence on these specific brain networks, potentially across women, but certainly across the 3 cases that we looked at. Patterns in brain areas involved in memory, language, and motor functions repeatedly appeared associated with menstrual cycle hormone changes, suggesting that the menstrual cycle can influence these specific functions, which we know just based on the reports of women's experiences across the menstrual cycle that this is true. The anterior cingulate gyrus also showed consistent connectivity alterations across the menstrual phases in all 3 cases, which suggests that there's a sensitivity of this specific region to hormonal, ovarian hormone levels and variations. Limitations of the study, of course, there were many. One of which was difficulty in accurately identifying the participants' menstrual phases. So this is something that I really want to highlight, and it's part of the reason why we don't include women in a lot of the research today, is because identifying and measuring and tracking all the different menstrual cycles of all the different women included in a study is a very, very large, laborious undertaking. It's very difficult to track, especially because even within subject, and really you always want to look at least 3 menstrual cycles so that you can compare and make sure that your data is viable. That the menstrual cycle can change even within subject. So there's a lot of variability between subjects, and then also within the subject, there's variability of the menstrual cycle. So it can be very difficult, and definitely was for me, to track all 40 participants' menstrual cycles and identify which phase they're in. And I did that by tracking their period start date and end date over the 3 cycles. There's also was a lack of control for external factors. So, what was happening within the lives of each of the subjects was not part of the study and was not tracked. And of course, this is the case with any study, but definitely was something that influences the um, variables that I measured within this study, but were not controlled for. Technology user error limitations. So we used the BioStrap wristband wearable devices. Um, the biggest challenge that we had was getting the subjects to wear them every single day and to keep them charged. It was asking a lot of the subjects because they had to do this every day for 3 full months. Um, and the wristband wearable devices needed to be charged just about every other day in order to consistently get the data. And so for the subjects that we didn't get consistent data, we had to unfortunately eliminate from the study. So we didn't end up with 40 viable subjects by the end. And then limited resources. Um, my study was very expensive for me personally. And I was lucky enough to work with a company that was willing to let me borrow the devices rather than purchase them. Um, but I only was able to get 40 devices and had to pay for any of them that got broken or weren't returned. And then also to get EEGs, 9 EEGs from all 4 subjects. 3 of them ended up making it into the study, was also a very expensive feat as well. So had I had more resources and more support for this study, I think it could have been a lot more robust. And then, of course, we can't generalize these findings and these results for clinical populations. So we didn't look at folks with neurological or mental health conditions. That wasn't included in the study. Conclusions and contributions. The findings of the study did provide compelling evidence of discernible patterns in brain activity and autonomic responses throughout the menstrual phases, which underscores there's an intricate relationship between the ovarian hormone shifts that happen across the menstrual cycle and global neurophysiological processes, which go well beyond reproductive mechanisms. By delving beyond conventional perceptions of the female hormone cycles as solely within the context of reproduction, this study sheds light on the multifaceted relationship between the female neurophysiology and the menstrual cycle, and provides a foundation for which future research endeavors in the field of women's neurophysiology can build upon. And it did raise a few questions that now other researchers and including myself are starting to look at. So I hope that this is just a very first baby step in expanding this type of research. And it really does highlight the need for more robust research in the realm of women's health generally, especially beyond reproduction. Suggestions for further research is to incorporate the consideration of hormone cycle phases in studies measuring sex differences, but also in studies that aren't necessarily looking at reproduction or hormone health. I think it's important to always consider the female hormone cycle and these different hormonal variations across the month in any data collection with any female subjects. To enhance the rigor and evaluation of female menstrual cycle research in clinical research and beyond reproduction, and to conduct more research on the physiological and health-related impacts of the menstrual cycle, and further research to better understand and fully map this female-specific biological rhythm.